Today's lesson is on 4.4, the fundamental theorem of calculus. The fundamental theorem of calculus. If a function f is continuous on the closed interval from a to b, and f is an antiderivative of the function on the interval from a to b, then we say that the integral from a to b, meaning your lower bound and your upper bound, I'm actually going to give you values of the function, is equal to the antiderivative of the upper bound minus the antiderivative of the lower bound, and the numbers have to be plugged in. Definite integral. So here we're going to go from a to b of the function, and that is going to equal to the antiderivative of the lower bound and the upper bound, which is the area of the upper minus the area of the lower. We're going to start off with some examples here. If I'm taking the antiderivative right here on 3x, remember the exponent is 1, so I'm going to add 1 to the exponent, so now that's going to be a 2, and whatever the exponent is, I'm going to divide by it. Right here, I have a 2, the antiderivative of 2 is 2x. And then, so now I'm going to take the antiderivative off in the dx, and I'm going to draw this line on the side, and the lower bound is 2 and the upper bound is 4. So once you take the antiderivative, you no longer write the integral symbol. You're going to draw this line and put your lower bound and your upper bound in. Now I'm going to go and plug in the upper bound into the antiderivative. So I'm going to first plug in the number 4 right here and right here. So this is going to be a 3 times a 4 squared divided by 2 plus 2 times a 4. You take your upper bound, and now I'm going to subtract the lower bound. So now I'm going to plug in the number 2. So that's 3 times 2 squared over 2 plus 2 times 2. So now when I go ahead and I plug this in the calculator, I get alpha y equals 3 times 4 squared as the numerator, in the denominator of a 2 plus 2 times 4. So this is going to equal a 32. Right here, alpha y equals 3 times 2 squared over 2 plus 2 times 2. This equals a 10. And 32 minus 10, that equals 22. So the area under this line from 2 to 4 is equal to 22. Go ahead and do another one. Right here, if I have 1 over x, that is the same as saying x to the negative 1 power. Don't forget your upper and your lower bound. Now I'm going to go ahead and take the antiderivative. If I take the antiderivative, when I add 1 to the exponent, that's going to be x to the 0 over 0. Right there, that should ring a red flag. I cannot do that. So that's actually one of the properties. This is actually one of the properties of integrals. I'm going to go and I can take the antiderivative here. That's going to be 2x. I'm going to add one of the exponents. That's going to be a 2 and then divide by 2. And that's going to be a 3x. And because I took the antiderivative, leave the integral off, and you write it like this. Now keep in mind, this right here cannot happen. That is a rule. That is actually the integral of 1 over x is natural log of x. So that's actually natural log of x. So if you take the derivative of natural log of x, it's 1 over x. Plus, here the 2's cancel, and I'm left with an x squared minus a 3x. I'm now going to plug in my upper bound. So first goes the 4. So first goes the 4. So it's going to be a natural log of 4 plus a 4 squared minus 3 times 4. Subtract. I'm now going to plug in the number 1. Natural log of 1 plus 1 squared minus 3 times 1. Now, right here, I don't know what the natural log of 4 is, but I know that 4 squared is 16 and 3 times 4 is 12. Those two are like terms, so I can put them together. So this is actually natural log of 4 plus 4. Subtract. Natural log of 1, you guys should know that the natural log of 1 equals 0. So this is a 0. 1 squared is 1. 3 times 1 is 3. 1 minus 3 is a negative 2. So a negative is going to make that a positive. So my final answer here is going to be natural log of 4 plus 6. Now let's say that answer does not show up. That can actually be manipulated. I can rewrite 4 as a 2 squared. And using the properties of logarithm, I can move the 2 out to the front. So that's 2 natural log of 2 plus 6. So this answer can be written both ways. You have to know how to manipulate it. All right, let's move on to the mean value theorem of integrals. Right here. If f is continuous on the closed interval from a to b, then there exists a number c in the closed interval from a to b such that the integral from a to b of the function is equal to f of c times the upper minus the lower. So in example 2, we're going to find the value or values of c that guarantee that. C that guarantee by the mean value theorem. So right there, that tells me I'm going to use this formula for integrals for the function over the given interval. So there's the function and there's your boundaries. I'm going to go ahead and graph this just to see what it looks like. I only care about 4 and 9. The square root of 4, that equals 2. The square root of 9 equals 3. And I know that this is a curve like this. So it looks like this. But the C value is going to be between 4 and 9. because we're only looking at that domain. Now keep in mind, if this is what I'm solving, if I'm trying to solve here for f of c, how do I get rid of the b minus a? I divide it to both sides. So in the long run, f of c is equal to 1 over b minus a times the antiderivative, the integral. So this is basically what I'm solving right here. So this is my a, this is my b. So f of c is equal to 1 over b minus a, so that's 9 minus 4 of the integral from 4 to 9. The square root of x, I'm going to write it as x to the 1/2. And then do not forget the dx, because you need the dx with the integral. So f of c is equal to 1 over 5. Now I'm going to take the antiderivative here. If I add 1/2 to the top power, 1/2 plus 1 is going to be 3/2, which means I have a 3/2 in the denominator. That 2 is going to flip up to the top, so that's going to be a 2 over 3. I'm going to take off the integral, and now I'm going to add this line. My lower bound is 4, my upper bound is 9. Now 2/3 is a constant. If you really wanted to, you could pull 2/3 out, so you'll have a 2 over 15. I'm just going to go and I'm just going to plug in the numbers now. Don't forget the 1/5 on the outside. So it's going to be 2 times 9 raised to 3/2 over 3. Upper, subtract the lower. So now I'm going to use my calculator and plug that in. So right here, I have a fraction, 2 times 9 raised to 3/2 over 3. So this equals 18. So I have a 1/5. This is an 18 minus, I'm going to go ahead and now plug the next one in. So I have a 2 times a 4 raised to the 3/2 over 3. And now this equals 16 over 3. I can type all this in my calculator and it will do it. It'll solve it out. So alpha y equals, there's my 1/5. I'm going to do my parenthesis. I have 18 minus, I'm going to do my fraction again, 16 over 3. And my answer is 38 over 15. Now, so 38 over 15. So this, if you type it in the calculator as a decimal, 38 divided by 15, this is approximately 2.533, which is between y. So right here, this is going to be the average value. So right here, this is between, and that is between y equals 2 and y equals 3. Now, keep in mind that f of c equals the square root of x, or I'm going to say the square root of c. So if you're trying to find out the value of c, right now I have 38 over 15. I'm going to square that, and that's going to actually give me what the c value currently equals. So the c is actually 1,444 over 225. That is your c value. All right, let's move on. This is a definition of the average value of a function on an interval. If f is integrable on the closed interval from a to b, then the average value of f on the interval is given by 1 over b minus a times the antiderivative from a to b of f of x dx. So in example 3, we are going to find the average value of the integral. So we have y equals sine x on the interval from 0 to pi halves. So this is your a, this is your b. I'm going to go ahead and write it like this. So I have 1 over, my b is pi over 2, my a is 0. The antiderivative, the lower bound is 0, the upper bound is pi over 2. The function is sine of x. And then don't forget your dx. Right here, this is going to be pi over 2, which the 2 is going to flip up to the top. So that's going to be a 2 over pi. And then the antiderivative of sine x is actually negative cosine x. Because the derivative of negative cosine is positive sine. Lower bound is 0, upper bound is pi halves. Make sure you take off the integral and the dx and you replace it with that line. I'm going to now plug in my upper bound and my lower bound. So I have a 2 pi. I have a negative cosine of pi halves. Subtract negative cosine of 0. Right here, a negative is going to make that a positive. And then here I'm left with the cosine of pi halves. That's going to be a 0. And the cosine of 0 is going to be a 1. So that's just going to be a 1. So the final answer here is 2 over pi. All right. Now last part. The last part of the notes is the second fundamental theorem of calculus. These ones are kind of easy to identify only because you have a variable on your boundaries, on your integrals. That's when we know that we're going to use this theorem. So on the second fundamental theorem of calculus, if f is continuous on an open interval I containing a, then for every x in the interval, we're going to have the derivative of the antiderivative. Now on the antiderivative, notice that there's a variable on the integral of the function, and that's going to equal f of x. So you are basically taking the derivative of the antiderivative. Now there's a shortcut to this, okay? Now I'm not saying a bad word here. It's going to sound like a bad word though, okay? This is called fucked up flow de low. Now let me tell you what each of these stand for, okay? So right here, the up means that you're going to plug the upper boundary into the function, okay? So you're going to plug the upper into the function. So whatever it is, you're going to go ahead and you're going to plug it in. Now, dup means you take the derivative of the upper bound. So whatever the upper bound is, you're going to take the derivative of that. So I'm going to plug the derivative, take the derivative of the upper. Now, flow means you plug the lower bound into the function. So plug lower into the function. And then d-low means you take the derivative of the lower bound. Now you're going to use when there's a variable on the integral. So last example, we are going to integrate. We are basically taking the derivative of the antiderivative. So we have d dx of 3x cubed cosine t dt. All right, so here we're going to start applying it. This is fucked up floaty low. How do I know that? Because I have a variable on the integral and I have a derivative of an antiderivative. So the first thing you're going to do is you're going to plug the upper into the function. So you see how it says x cubed? I'm going to plug that into the function. So that's going to be a cosine x cubed. So this is a cosine x cubed. Okay, this is the fup part. Times, now the dup part is you take the derivative of the upper bound. So what is the derivative of x cubed? The derivative of x cubed is 3x squared. So that is the dup part. Subtract, flow, you plug the lower bound into the function. So this 3 is now going to get plugged into the function. So that's cosine of 3. And then d low is the derivative of the bottom. Well, the derivative of 3 is a constant, so that's just going to be a 0. That's nice, because right here, 0 times anything goes away. So then your final answer here is going to be the cosine x cubed times 3x squared, which typically this is going to go in front of the trig. And that's it. Let's try one more. Try one more. If you want, go ahead and hit pause and try it on your own. So go ahead and try it on your own. You can hit pause and then hit play when you're done with it. So fup, I'm going to plug the upper bound into the function. So this is going to be an x cubed. Dup means take the derivative of the upper. The derivative of x is a 1. Minus flow, you plug the lower bound into the function. So that's going to be a negative x to the 3rd power. And then d low means the derivative of the bottom, and the derivative of the bottom bound, which is a negative 1. So now right here, when I multiply that, that's going to be an x cubed. Right here, a negative x to the 3rd power, that's a negative times a negative times a negative, which is a negative. So if that's a negative, and then that's a negative, that's going to be a positive, correct? So this is going to end up being a positive x cubed, but I have the minus in the front. And then the final answer is going to be a 0 here. And that concludes our notes.